Engine performance 2, test 11 and 12, temperature and position sensors. We've talked about sensors a lot of times in here before, but the way that we do is we saturate you with sensor stuff so you can learn lots of things. The sensor that most determines fuel delivery when a fuel-injected engine is first started is the
oxygen sensor?
Please. The oxygen sensor is not even online until it warms up and gets started.
It's a coolant sensor.
That's engine coolant temperature sensor. Lundy was throwing me a curve. That's what he was doing.
I wanted to see if you were awake.
Yeah. What happens to, hey, I've got coffee here, okay? What happens to the voltage that measures the ECT sensor when the thermostat opens?
I'd say it decreases slightly.
What? Decreases?
I don't know.
Number 2. What about it? Think about it. Whenever you first go in there and look at your scan tool, Willie, look at your scan tool. On your engine coolant temperature sensor on a cold engine, you see about what? If the engine's cold, what's the voltage look like on the engine coolant temperature sensor? No, it's 2.5, 3 volts, something like that.
Yeah.
And then as it warms up, the voltage drops. All right. So no, wait a minute. What happens when the thermostat opens? What goes on?
It increases
It increases slightly, okay? It goes up a little bit because it gets some cool water going across it because the thermostat open, and you're getting, water from the radiator. All right, now this here's the other thing. You can actually watch your, what's all that printing going on over there? Huh? Oh, you're probably right because he's printing from out there. Okay.
They fixed it.
Is that
Dodge Charger.
that's the charger he's pulling the transmission out of? Okay. All right. I was surprised by that.
So it increases slightly.
It increases slightly, but what I'm saying is you can take a scan tool and check your thermostat. That's the point. You got me? Take a scan tool, check your thermostat. It'll go. You can either look at the voltage or you can look at the temperature. If the temperature goes up about just over 200 and then it drops down to about 180, then it goes back up. You're going to know your thermostat's opening.
Okay, so all sensors don't start at 5.
Temperature? No, they're not going to start there. You're only going to see 5 if something's wrong.
Something wrong.
Yeah. I mean, even if you unplug an engine coolant sensor, it's only going to show 4.6. It's not going to go all the way to 5 because it's got a little current limiting resistor inside there. 2 technicians are discussing a stepped engine coolant temperature circuit. All right. Let me see who this is. Hello.
All right, man. Good news.
All right.
We've got it built out. $715 is the price as far as parts only. The year parts and labor's an additional $176. Then you got the 150 core. I've got on there must ride tomorrow. Customer closes at 4:30. Fridays they close at lunch.
That's good, Zach. You're a good man, buddy. Appreciate it.
All right, thank you, sir.
All right. All right, we got an engine coming. Let's see. 2 technicians are discussing a stepped engine coolant temperature circuit. Technician A says the sensor used for a stepped circuit is different from the one used for a non-stepped circuit. Technician B says the stepped ECT circuit uses different internal resistance inside the PCM. Have you guys checked that out ever? That's actually going to be a B.
Really?
That's inside the PCM. It's not the sensor itself. And the step sensor, think of the step sensor as a sensor that changes gears. Because what does the coolant? What does it do? It's going to start out up here. Let's say it starts out at 3.2 volts. And if you plotted it on a graph, it's going to slowly go down with the bottom of your graph here. All right, when it gets down in this territory here, it's dropping pretty fast. It can't really accurately tell you anything when it's already that low, can it?
Nope.
Okay, so what it does, you're going to watch this happen, like on that Oldsmobile and some of the Chrysler stuff and all that. When it hits about right there, it's going to make a jump and then it's going to go down again. It's like shifting gears. That's basically what a step sensor does. Now on the Ford, they don't do that. But on a Ford, if you drew that on a graph, the Ford would do this.
You're obviously not reading that from the actual sensor itself.
Yeah. You can actually get on the voltage on that sensor will do that same thing, but it's inside the PCM where the change is being made. Okay. I've actually got a diagram of that showing you how it works on the thing I did on on Duramax diesel, because they do that. But I'd have to pull all that up, and even after I got through explaining it to you, you'd say, yeah, whatever, let's move on, So anyway, When testing an ECT sensor on a vehicle, a digital multimeter can be used and the signal wires back probed. What settings should the technician use to test the sensor?
DC volts.
Direct current volts, that's right. Number 5, when testing the engine coolant temperature sensor with the connector disconnected, the technician should select what position on the digital multimeter.
That's going to be ohms, isn't it?
Yeah, it's going to be ohms. We're going to ohm that thing out. Now, Ford used to have this silly stuff in their shop manual back in the 80s, and they would tell you to unplug the sensor while the engine was running and check the resistance of that sensor, which is the stupidest fool thing I ever heard. I started back probing it, looking at voltage, because that way you're not disturbing anything and you're going to fix more cars that way. And I sent in some best ideas contest things about how I would check voltage at sensors and I'm looking at what the PCM's seeing, and if you know what a good one's supposed to look like, you'll know a bad one when you see it. The most important thing you can do is every time you get a chance, plug a scan tool in and look and see what it looks like on a good car. You know, as a matter of fact, when we're doing these vehicle inspections, it wouldn't be a bad idea to plug a scan tool in and just go through those things and look at them and see what you're used to seeing. And when you look at enough good ones, as soon as you see a bad one, you'll say, I'm used to seeing 4 grams per second on that mass airflow sensor. I know 8 grams per second with the engine idling is wrong. You see what I'm saying? But if you had never seen it before, when you look in there, you can have a problem glaring right in your face, and you don't even know what you're looking at. See what I'm saying? So the most important thing you can do in here, and you guys need to be digging into some of your emission worksheets, because a lot of you are really far behind on emission worksheets. That means no standing around a shop with your arms folded or helping other people, because you're not getting any of your worksheets done that way. You got me? All right. Now then, let's see. When checking an ECT sensor with a scan tool, what temperature should be displayed if the connector is removed from the sensor with the key on, engine off? 40 below zero is what you're going to see. However, listen to this. Let's back up and make a caveat on that. Remember, I told you there's two different ways you can go into the scan tool. One is just OBD2 generic, and the other one is enhanced. Enhanced is when you're looking at what the manufacturer puts out there for you to see. The OBD2 generic is the worldwide, everybody does it the same way. When you plug it in and you go into your enhanced room, you're not going to see 40 below on most of them. You're going to see a value that's been substituted that they feel like is most likely to work. Got me? You understand what I'm saying? I mean, is this clear? If you plug that one in, if you see, and it's on a hot day, you may have a problem. Let's say I'm pulling a code, and I'm seeing an engine coolant temperature sensor that's throwing me a code, PO118 or whatever the sound hell it is. I don't have them all memorized. But the thing about it is, I say, now I'm going to go into my enhanced data stream and I'm going to see what I see. Well, let's say it's a hot day, and you're reading, that sensor is reading about 110 degrees and saying it happens to match what the intake air temperature is because it's a hot day, and you're thinking, well, I don't really see anything unusual about this reading. Well, if you backed out of there and you went into the into the OBD2 generic room and that sensor was unplugged, you'd see 40 below. But if you go into the enhanced room with it unplugged, you're liable to see 111 degrees. Because it's going to say, when they type those algorithms, they're thinking, well, we want this thing to make its calculations based on a value that will probably be okay if there's something wrong. You understand what I'm saying? And so you're not going to see 40 below with a scan tool in there. See, they didn't really write this question well, because they should have said when checking it with a scan tool in OBD2 generic mode, it's not going to be the same. Now remember that. Also, there's 2 rooms in that engine controller. Sometimes you'll get codes out of the enhanced room that you won't get out of the generic room. Actually, it's the other way around. Usually the generic room has everything in it, and the enhanced room won't always have everything. And that kind of stuff. So, yeah.
I don't know which transmission it is.
I don't know. You'll have to look at description and operation in the transmission section. See what it's showing.
Well, no, I'm saying on there it says there's like 3 different ones.
Well, application and ID. You're going to see there's a link on all that. It says application and ID. You click on that one and it should tell you how you find out.
Okay.
All right. Let me see here. Let's see. 2 technicians are discussing the intake air temperature sensor. Technician A says the intake air temperature sensor is more important to the operation of the engine which means it has higher authority than the ECT sensor. Technician B says the PCM will add fuel if the IAT indicates the incoming air temperature is cold. He's right about that. That's B. All right, now I always have to stop right here and tell the story of the Dodge. Some of you may have heard it before. The Dodge pickup comes in when the weather's cold to the body shop, and somebody T-boned it or whatever, and they had to do a bunch of work on it. They've just about got it completely fixed. I happened to be over there on one of my days off at the Ford place, and I says, is there anything I can help you guys with that nobody has time to get to? And they said, well, the body shop has got a Dodge over there that won't start. It was starting when it came in here, and it ain't starting now. And so I go over there, and I smell gas. And I said, okay, so we got spark, but I'm smelling gas. So let's pull the plugs and see if they're wet. Well, they were soaking wet. So I'm going to put a set of plugs in it before I do anything else. So I put a set of plugs in it. It didn't take long to do that. It was easy to get to. And I noticed when I looked at my scan tool that a couple of things. I've got an intake air temperature sensor that's reading that it's open. All right, I go into the enhanced on the DRB3, which is the Chrysler Strand School in those days. It was reading 111, like I was talking about a while ago. I go into OBD2, and it's reading 40 below. All right, I said, okay, this intake air temperature sensor looks brand new. So I unplug the wire, I get my meter, and I'm going to check, and I got 5 volt, or I got 4.6 volts there, which is what I was talking about. I say, well, there's voltage here, and the other one's grounded, because the two wires go into the sensor. One of them's going to have 4.6 when it's unplugged, and the other one's going to show a ground. This is good. This is all the way in. I measure that sensor, and it's wide open. This is the scenario I'm thinking about. They went to the parts house where Lundy works over there, and they pulled the code. It threw a sensor code. They put a sensor in there, and the sensor they put in there was as sorry as the one they took out. Yeah. And then when the code came back, they says, well, you must have other problems. I don't know what else to do. And so they left him out of there. But it was still starting okay because the engine coolant was 40 anyway whenever he started it cold. And that pretty well, it was warm weather. That's because it was pretty close to what that thing was factoring in. It was 111 here and maybe 80 or 90 here because it was hot summertime. Now we had a cold snap. It goes down to 40 below. Well, now the engine coolant's reading 40 degrees, which is what the outside temperature is. The intake air temperature is reading 111, and it's thinking, goodness gracious, I've got really cold engine here and hot air, and so I'm going to use that to decide how much fuel I'm going to put in there, and it was just flushing fuel in there. Okay, so the way I determined what was wrong, I got my little, let me see that thing right there stuck to that magnet. What's there? What's there? What's there? Give me that. That one. That's it. That's it. Give me that. Okay, so I get my little potentiometer right here, my little that I got from Radio Shack for $4 or $5, and I hook up to 2 of these leads, the middle one and one of the other ones. Doesn't matter as long as one of them's hooked to the middle one. And I hook it to the engine coolant sensor, and I turn that. This has got like a 50,000 ohm pot. This one here is like 1,000 ohm, but you want a 50,000 ohm. And I turn that knob and I watch my scan tool until I've dialed the intake air temperature. I'm hooked to the 2 wires coming off the intake air temperature sensor. I turn that knob until they match. Until the intake air temperature and engine coolant temperature are reading the same. See, this has become my intake air temperature sensor, but instead of using temperature, I'm using my knob to change it. And when I got them to where they matched, I turned the key and we started up. We're good to go. So we needed a good intake air temperature sensor.
So it was flooding the system?
Basically, we were pumping too much gas in there. When you wet the spark plugs, the spark runs on the wet gas instead of jumping across the gap, and you don't get no, ignition. Yeah, you got spark, but there's no spark happening at the tip of the plug. All right. So anyway, everybody understand where we went with that?
Yeah.
One of these, about a 50,000 ohm one in your toolbox, doesn't cost very much money. And you can just get a couple of silly little jumper wires. Don't damage the terminals on the intake air temperature sensor. Go in there real gentle with them little things I showed you, or back probe or whatever with paper clip or the little T-pins, and go to those 2 wires and you can dial in what you want. Something else you can do with this, you can dial that. You got to have the engine running on some of them, but if you don't see the coolant fan works, you dial that thing up to where it thinks the engine's hot using the engine coolant sensor. You can make that fan kick on with one of these. You're fooling the controller into thinking, and you'll hear it change sounds in the way the engine runs too, because it's factoring things in for idle control and all that. This is one of the most useful tools you can have in your toolbox, and it costs almost nothing compared to most of the other tools you get. Just a little potentiometer like you buy from Radio Shack. Real cheap, real handy. All right. I've talked about that before, but I wanted to make sure that I covered it again because I like to bore everybody to tears, and everybody in here is turning into a skeleton. All right, so you know what hoo-ah really means? That means I got it, okay? All right, yeah. Okay, when, let's see, two technicians are discussing, wait a minute, if the transmission fluid temperature sensor indicates cold automatic transmission fluid, what would the PCM do to the transmission shifts?
Delayed shift points and torque converter clutch disabled.
Yeah. Now, why would it disable the torque converter clutch? What's that got to do with anything?
I don't know.
Because torque converter is what, pressure is, when the transmission get hot, and the torque converter is the one that throws the fluid on.
Well, it is, but the torque converter creates heat.
Yeah.
Because it's shearing that fluid, the torque converter is creating heat. And we want to warm the transmission up quicker. So if we don't lock the torque converter, it's still shearing fluid. See, if you lock it up, it ain't shearing fluid no more, and it makes it run cooler. Okay, so if you unlock it, well, if it's cutting that fluid, it's going to be creating heat, because the heat in the automatic transmission comes from the torque converter. So we want the transmission to get warm quicker. So we're going to let it shear fluid and heat that transmission up quicker. See, if the transmission fluid is cold, we want it to get warmed up so that everything will work more, more better. Yeah. Okay, so he was right about that. A PO 118 diagnostic trouble code is being discussed. Technician A says the ECT sensor could be shorted internally. Technician B says the signal wire could be open. Who is right about that? That's going to be B. Technician B. That's if you got it unplugged. In the illustration below, what type of circuit is depicted? In the illustration below, what type of circuit is depicted? Anybody know? Anybody? Or is everybody just waiting for me to spoon feed them the answer? What?
Yes.
Negative temperature coefficient thermistor circuit. That means that the warmer it gets, the lower the resistance goes, and the lower the voltage goes. Because as that resistance gets lower, it shortens that 5 volts away and making the voltage go lower. The intake air temperature sensor is being tested after the vehicle has been allowed to cool for several hours. A scan tool is used to observe the IAT and compare it to the engine coolant temperature sensor. The two temperatures should be within how many degrees Fahrenheit of each other? 5 degrees. They got to be really, really close. If you look at transmission, if it's been sitting there a long time, let's look at our transmission oil temperature, let's look at our engine coolant temperature, let's look at our intake air temperature, and they all will be real close together. What if one of them's way off toward McDuff's? If one of them's way out of line with the other two, we're going to suspect that sensor's got a problem with it. You got me?
Yes.
All right. Okay, which sensor is generally considered to be the electronic accelerator pump of a fuel-injected engine? Ding, ding,
Position
ding.
sensor.
Yeah, the TP sensor. That's and one of the parts guys at Bondi's used to call that the wigwam indicator. All right, you can figure out why he called it that. Typical TP sensor voltage at idle is about what? Anybody talking out of their hat here?
I'm gonna go 2.5.
No, at idle, it's going to be, now this guy's a GM lover, you can tell. Because on GM cars, it's usually about a half a volt, and on Ford cars, it's usually up close to a volt. But it says half a volt or 10% of wide open throttle sensor voltage. That's the way they figure. Okay, number 14. Now remember now, a TP sensor ought to read somewhere between a half and 1 volt. Now, let me ask you this. When you, remember this now, when you crank that car up, the first thing it sees, you're not supposed to be jacking around with the throttle whenever you're trying to start the car. Because what it sees when you turn the key on is closed throttle. And whenever you turn on the key, it says, what I'm seeing right now is what I'm gonna draw a line right there. Your engine controller sees wherever that throttle position sensor is, and it draws a line. And it says, okay, I'm gonna call that CT. If you're fooling with it, it confuses it, because it won't know what it is. All right, now then, let's say if you're in a situation, whenever you give it gas and it's driving down the road, you got your idle air control that's going to go into dash pot function. Now, a dash pot was an old diaphragm that was catch the throttle lever on a carburetor and lower it slowly so that it didn't slap shut and kill the, cause the engine to stall, because the engine needs to slow down, slowly. And these electronic fuel-injected vehicles, they go to 100%, when you're driving, and then whenever you let off, they come down slowly. so that it won't stall. I mean, that's called dashpot function. Your idle air controls do it. All of these electronic throttle bodies, they all do it. Well, let's say that for some strange reason you got a little resistance on your throttle position sensor circuit. It's going to see a little bit above closed throttle, and you're coming to a stop. You know, if it's got that problem. Let's say that this voltage right here is 0.7. You know, let's say 0.75. We're just going to put a number out there because it can float a little bit as long as it looks at it and sees something accurate. Let's say that when you let all the way off the throttle or something going on in that circuit, the throttle position sensor is bad or your wires need to be soldered and they're crimps or something like that, and this thing is up around 0.81 when you let all the way off, it's going to think you're still giving it a little gas, and it's going to hold that dash pot up. So you're going to let off, and when you pull to the stop, the engine's going to be going, and then you jack around with those wires or something, and then this drops back down to 0.75, and it says, okay, now I'm at closed throttle. On your scan tool, when you're at part throttle, that'll be your key. See what I'm saying? If I'm revved up when I pull to a stop, I'm going to look at my throttle, and I'm going to see if I'm at closed throttle or part throttle. If I'm at part throttle and this is a little bit higher, that's why a lot of your scan tools have actually got what closed throttle is. They record that. You know, the engine, they'll actually get a snapshot from the computer of what it sees as closed throttle. And when you let off, if it's higher than that, that's going to cause the idle to be elevated when you stop and this kind of thing. Is everybody listening? You got what I've got? You see where I'm going with that? Now, when you begin to get to where you think, when you got to learn to wear that scan tool. You know what I mean in your mind? Now, I'm not saying you need to have it between you and the airbag while you're driving down the road. You know what I'm saying? Because that could knock your head clean off if you run into something. I don't like the airbag being on the horn pad anyway. I got a lot of specs because you're going, honk, boo, you know, that thing blowing up in your hand. All right, anyway, how did I get on the airbags? All right, now then, that right there is negative temperature coefficient. Let's see, which sensor is generally considered to be electronic accelerator pump TP sensor? Typical TP sensor voltage at idle is half. The TP sensor is what kind of sensor type?
Potentiometer.
Potentiometer. Which of these sensors does the TP sensor back up if the PCM determines a failure has occurred? Either B or C. Either B or C. One of the, you know. All right, that page, Paul Harvey, page 2. Okay. Okay. Which wire on a typical TP sensor should be back probed to check the voltage signal to the PCM? Yeah, that's not too terribly hard, is it? The signal wire. All right, what are your 3 wires you got on a TP?
Signal wire, ground, and the PCM.
Yeah, you got reference, ground, and signal wire, correct? Okay, so if you connect it between a 5-volt reference and ground, what do you read? Don't play dumb with me. If you connect it between the 5-volt reference and ground, you read 5 volts.
5 volts.
Okay. Yeah, I was not trying to be a trick question. After a TP sensor has been tested using the min-max function on a DMM, a reading of 5 volts is displayed. What does this indicate?
I didn't read what you just read.
After a throttle position sensor has been tested using the minimum-maximum function on a digital multimeter, a reading of 5 volts is displayed.
Saying 5, but mine says 0.
It's zero.
Yeah, it says 0.
Are you serious?
Yeah.
Oh, you mean the test that I have says... No, I'm sorry. I read question 18, and it says 5 volts. I jumped a question. After a TP sensor has been tested using a min-max function, the reading of 0 volts is displayed. What does that indicate? That's number 17.
Sensor shorted.
The sensor's open at one point during the test, right? Or you can have, one of the things they're leaving out here, if you took if that wire, the signal wire, let's say that it's rubbed against an air conditioner line until it's rubbed all the insulation off, and that little gray wire with the white stripe that carries the signal is touching that air conditioner line, sometimes when the engine torques, it'll cause that same kind of problem. It'll go to, you know, your min-max function is going to show you where the voltage has been. You saw that on that meter the other day, didn't you? It'll show you the highest it's been, it'll show you the lowest it's been, it'll show you what it is right now. And if you see the minimum and the maximum, which is a really fast snapshot, has gone either way up or way down, you got a glitch there. And that's when you switch over to scope mode and you set it on glitch. You're going to put your trigger up there in the area where the voltage should never be. And whenever it happens, bam, it'll give you draw you a picture of that if it goes into that range. That's when you're driving down the road trying to get one to act up. Let's see, if it displays 5 volts under those circumstances, which is number 18, you could have B or C. The TP sensor is either shorted or the signal is shorted to 5-volt reference. So those, number 17, the answers weren't well written, I don't think. A technician attaches one lead of a digital voltmeter to the ground terminal of the TP sensor and the other meter lead to the negative terminal of the battery. The ignition is turned on, the engine is off, the meter displays 37.3 millivolts. Technician A says this is a signal voltage and is a little low. Technician B says the TP sensor ground circuit has excessive resistance. All right, so what do you think about it? What's he actually checking here?
He's checking a draw.
No, wait a minute, not a draw. You did it the other day on the Escort.
Yeah, I just,
Voltage drop.
that's it.
Now you're checking the voltage drop.
Some people out here.
Yeah, well, okay, tell them that I'll be with them in just a minute. I'm almost through in here. Give 5 minutes. Okay,
And that's B,
okay.
right?
PO 122 diagnostic trouble. Yeah, I'm sorry. Number 19 is D. We got 4 questions left. We're almost through. We're trying to keep this at less than 30 minutes.
Dog,
Huh?
D is dog, or B is boy?
Oh, I should have showed, let's see, why don't we say delta or something like that, okay? Okay, we're gonna have, it's gonna be, that was 19, wasn't it?
Yes.
Okay, that's neither A nor B. See, actually, that's not excessive when it comes to, voltage drop. PO 122 diagnostic trouble code is retrieved using a scan tool. This diagnostic trouble code means what? All of the above. The voltage is low, could be shorted to ground, the signal could be shorted to ground. Technician A says the 3 wires on the TP sensor include a 5-volt reference to the PCM. Technician B says the TP sensor is a 3-wire variable resistor called a rheostat. Okay, he's wrong. That's A only. And then 22, we got one more question after this one. TP sensor affects the operation of all the following except what?
B.
That's B, correcting for rich lean air fuel mixtures. It does not do that. That's fuel trim stuff. A typical TP sensor registers how many volts at wide open throttle?
4.5.
4.5. So, what's that? Oh, it sounds like Zach blew something up out there. All right.